change. And it can impose cost to the society by creating this deadweight loss. So that was very interesting. Now what we're going to do, we are going to move back one step and move back to our original market model of demand and supply and try to understand how do we really measure response of the market to changes in market conditions. Market conditions mean changes in price, like changes in income, like changes in the price of related goods. We are again going back to the basics and try to understand something called elasticity. Elasticity is a very important and very quantitatively rigorous concept where we are in this chapter we're going to learn about how we can interpret the shape of our demand curve and our supply curve. What does different shape of demand curve or supply curve really mean for us? And what can we learn about the good in question when we look at the nature of a certain demand curve? Because not all demand curves have same shape or slope. In order to understand all these, we are going to come up with a mathematical formulation called elasticity, which really gives you a number that tells you how much consumers or sellers respond to a given change in price. So, to put it in a very simple words, we are now going to try to understand the responsiveness of the market to changes in market price. How much do consumers respond to changes in price? How much producers or suppliers respond to price? After covering that, we are going to look at how the demand and supply really responds to other kind of changes in the market. Most importantly, income. Income is a very important determinant that really affects mainly the consumer side or the buyer side of the market. So our objective is to understand this idea called elasticity. Today we are going to mainly focus on elasticity concept on the demand side. We are going to talk about something called price elasticity of demand, and then we are going to look at how this price elasticity of demand is calculated, what does this number really tell us, and how does this number change? Meaning, we are going to look at some determinant of price elasticity of demand. These two alone will be sufficient, are so lengthy that we might actually end up in the our entire class today. So let us start without further delay. Okay, so let's look at some statements, right? From September 2011 to September 2012, the price of gasoline rose for about 7%, and at the same time, gasoline consumption fell by 5%. What do we know about this? What can we learn about this number? These are statistics. It told you that between a time, price went down by 7%. Price went up by 7%. Quantity consumption, which is how much gasoline people were buying, fell down by 5%. First of all, notice that this makes perfect sense. This is law of demand, right? When price goes up, people buy less. That's exactly what you are seeing. Now we, from a market perspective, want to understand this responsiveness in greater detail, because our market model of supply and demand is an empirical model. Like firms, consumers, buyers, government, everyone looks at this market and tries to acquire important information about the market. When sellers are trying to sell a good, they need to really know how much the buyers respond to changes in price. When a buyer is buying something from a market, he or she needs to know what kind of good he or she is buying, because not all goods are same. There are goods like insulin for which you really don't care about the price. Regardless of what the price is, you are going to buy a certain quantity of insulin. I'm sure everyone is familiar with what insulin is. It's a life-saving medication without which you die. Now, as opposed to insulin, you can argue that people are very much flexible about whether they want to buy a Lamborghini or not, right? It's a very expensive car. right? In your regular day-to-day market activity, you really don't think about buying a Lamborghini, right? What about you suddenly receive a 70% discount on a price of a luxury good, which you really think about buying? How do you respond to that? It's a very important question, right? It's a very, very important question. Why? Because you see this information on a frequent basis in the market. Every now and then you will see that there is a 70% discount on a cruise ship ride. I'm not making this up, right? You see that. Most of the cruise ship ride, which are actually luxury cruise ships, always provide you with like really large discounts. But when it comes to Levi's, you rarely get any price discount. Over the last 10 to 15 years, I have noticed that there are some products for which you rarely get any discount. And Levi's is one of them. They rarely give any discount. Why?
They don't need to.
Who said that? That's a very good answer. Why do they not need to?
I mean, those people that wear Levi's have probably been wearing it for a while.
Yeah, because they're gonna. Well, that's a very interesting point. Is that there's a durability issue there. That's an interesting point. There could also be something called brand loyalty, where where Levi's knows that people are going to buy their product anyway. Anyways, that's a very strong statement, right? When you feel like people are already buying the product, you really do not want to provide any kind of discount or do any kind of marketing. Okay? So all these very critical marketing decisions, production decisions, purchasing decisions are based on how much do we respond to changes in market, like price, changes in our income, right? So we really need some kind of formula, some kind of number, some kind of quantity measure that can measure our responsiveness towards changes in price. The buyer's responsiveness to changes in price, which we are going to call price elasticity of demand, seller's responsiveness to price, which we will call price elasticity of supply, and buyer's responsiveness to changes in their income. Because when our income changes, we also behave differently. When our income goes up and we are thinking about buying ramen noodles, we surely don't want to buy ramen noodles when our income is going up, right? Are we all clear on that? So there are different goods in the market for which our responsiveness could be fundamentally different and interesting. And that's what we are going to try to understand in this very lengthy chapter. Okay, so to begin with, these are the kind of information that you regularly see in the market. So the motivation behind this number is that people do respond to incentives. In order to sell more, you really need to offer a price cut. Or sometimes when you offer a price hike, when you raise the price, you're going to see something like what is happening here. People buy less. So therefore, for a firm, changing the price, either raising it up or raising it down, is a critical issue for them. Because what price they charge will determine what profit they earn, which we're going to look at in some future chapter. So a firm is very careful about charging the price. Now, in order to charge the proper price, our firm needs to figure out how much does the buyer respond to those price changes. So the seller really needs to know this idea of price elasticity of demand. Now we can argue, and we have already seen that before, that how much or how we respond to price changes really depends on what kind of people we are. A major part of the behavior in the market is governed by our intrinsic ideas, like our taste, like what kind of people we are we risk lover or risk taker, what kind of income we have, are we rich or are we poor. These are behavioral issues that are interesting to analyze, and we're going to look at them. Okay, so if we go back to the numbers that we just looked at, a 7% rise in price leads to a 5% reduction in the demand for gasoline. Is that a big deal? Is that a big deal? Should sellers of gasoline be worried about the fact that whenever they raise the price by 7%, quantity demanded really went down by 5%? Now you have to be very careful about this, right? You might think that a 5% decline in the quantity of gasoline is not a big deal, but it is. Right? Why? Because you are talking about millions of gallons of gasoline, and a 5% of that is a whole lot of gasoline, right? What about a 7% increase in the gasoline price? Now that is not big, right? The gasoline price is about $1.85 right now, I think. And 7% increase in price of gasoline probably is worth like, increasing the gasoline price like 5 cents. Do we really care? Do we really care about that much price increase? The answer is surprising. We do care about price changes. Now, how much we care about those price changes really depend on what kind of goods we are looking at. And we're going to look at that. Okay, so in order to really understand how consumers respond to changes in price, the starting point has to be our demand curve. The starting point has to be our demand curve. Because our demand curve provides us with a lot of information about how consumers respond to price, right? So imagine that this is your standard demand curve. You have P and Q, and you have a downward sloping demand curve. And whenever the price goes down from P1 to P2, our demand increases from Q1 to Q2. So your demand curve provides you with the critical information about how quantity changes from Q1 to Q2 when prices changes from P1 to P2. So we somehow need to really explore the properties of this demand curve to get a more constructive or more rigorous understanding of this responsiveness. Okay, the starting point of this relationship is the slope of the demand curve. So what is slope? Slope is defined as rise over run. Is everyone familiar with this concept, slope? For a curve, let's say the one that we're looking at, demand curve. Let's say this is point A and this is point B. Slope is rise over the run, which means you measure the vertical axis, which is OA, divided by you measure the horizontal axis, which is OB, and that's your slope. The slope really gives you a good idea about how consumption quantity demanded changes whenever price change. So it gives you a ratio, and the ratio really gives you an idea about the changes in the behavior of our consumer in terms of how much they want to buy. Right? The shape of the demand curve is important because different slope will have different kind of demand curves. For example, we know that if our demand curve has a smaller horizontal intercept, this demand curve has a larger slope than the one where the horizontal intercept is larger. So the first one has a larger slope. This one has a smaller slope. Okay? A larger slope of a demand curve is called a steep demand curve, and a smaller slope of a demand curve is called a flatter demand curve. So, if your demand curve is a steep one, you know that for a given change in price, the change in quantity demanded is much smaller, right? You can see that for changes in price, the changes in quantity demanded is captured by a very small horizontal intercept. Do you all see that? It is very important that we understand slope, because without understanding slope, we will not be able to understand elasticity. So I'm going to stop and I'll take questions. Are we all clear on the fact that for a steeper demand curve, for the same given price change, our responsiveness on quantity demanded is smaller? Let's convince ourselves that it makes sense. Let's convince ourselves by looking at two demand curves which looks like this, D1 and D2. Okay? you can see that demand 1 is elastic. Okay. Now, obviously, you can have a situation where your quantity demanded, elasticity of demand can be, I don't know what's wrong with the. Obviously, we can have a situation where price elasticity of demand can be like 2%, 2%. For a 2% decline in price, your quantity demanded increases by exactly 2%, so it's going to be like -1. So if we look at the absolute value, which is equal to 1, we call it unit elastic. Okay? Unit elasticity is when the price elasticity of demand is exactly 1 without ignoring the negative sign. So what we want to now understand is the distinction between these three different kinds of elasticity of demand we just talked about. One, where absolute measurement is greater than 1. We call it elastic demand. Then the other one where elasticity of demand is less than 1, we call it inelastic demand, and sometimes equal, unit elastic, where the price elasticity of demand is just 1, and we call it unit elastic. So the question is, what does these numbers mean? What does these numbers mean actually? First of all, coming back to the graph that I talked about a little bit before, you can see that in D1, for a given change in price from $4 to $3.70, which is like 30-cent decline, your quantity demanded increases from 1,000 to 1,200. So if you do the calculation, you will realize that for D1, your price elasticity of demand is greater than 1, which means that your D1 is an elastic demand curve, and for D2, it is going to be inelastic because the change is going to be less than 1. Okay? So, if you are given any 2 points like A and B or A and C, meaning that you know 2 for prices and 2 quantities, and you're asked to calculate the price elasticity of demand, you should be able to calculate that. How? Let's now look at how we can calculate price elasticity of demand. I guess we need a little bit of space. We are going to talk about 2 methods of calculating price elasticity of demand. I'm going to draw the demand curve in the one that you looked at in the previous one. So I had a 2 demand curve. One was like this, the other one was like that, and then this was like $4 and $3.70. So this is $4, and this was $3.70. So $3.70. You had 2 different kind of quantity demanded. So the original quantity demand was 1,000, 1,050, and 1,200. 1,000, 1,050, and 2,000. So A, B, C, A, B, C. This is D1. This is D2. Okay. The price elasticity of demand, which is always written as something that is barely readable, its price elasticity of demand is percentage. I think I somehow have caused a problem to this. So it's percentage change in, okay, so Okay, so it's gonna be percentage change in quantity demanded divided by percentage change in price. The delta sign is for change. So for D1, notice that percentage change in quantity demanded, I need a space. This is very unfortunate. I really apologize. I have somehow ruined this one. I'll try to use it again. So first I want to calculate percentage change in quantity demanded. I have to use a board. I apologize. None of these are working. I hope that you guys can see that. Okay, so since I'm going to be using a board, let's go back to the actual figure so that you can see. So I am first looking at my D1, where percentage change in quantity demanded is you take the new value, you subtract the old value, you divide by the new value, you divide by the old value times 100. That's how you calculate percentage change. You take the new value of the variable, from that you subtract the old value and you divide by 100, by the old value and you multiply that by 100. So in that case, for our D1, our old value is 1,000 because we are assuming prices are going down from $4 to $3 and from $4 to $3.30. So our new quantity is 1,200. Old quantity is 1,000 divided by old quantity times 100. So it is 200 divided by 1,000 times 100. You can subtract those and it is 20%. That's percentage change in quantity demanded. Percentage change in price is the new price, which is $3.70 minus 4 divided by 4 times 100. Notice that there is a negative sign there. It is 0.3 divided by 4 times 100. Okay? So if you have that, this is going to be 30 minus 30 divided by 4, which is minus 7.5%. So you have percentage change in quantity demanded, which is 20%, percentage change in price 7.5%, and we can now calculate elasticity of demand, which is the ratio of these two. So I take the percentage change in quantity demanded in the numerator, percentage change in price in the denominator. Can anyone calculate this for me? What's the number? 20 divided by 7.5. What's the number? 2.66. It is minus 2.66. When you look at the absolute value of the elasticity of demand, this is greater than 1, so your demand is elastic. Right? Make sense? Now look at demand curve 2. In demand curve 2, percentage change in quantity demanded is 1200 minus 1050. I think I'm making a mistake. It's 1050. It's 1050 minus 1000 divided by 1000 times 100. So it's about 50 divided by 1000 times 100. I cancel those. It's just 5%. My percentage change in price is again 7.5, right? Because it's the same price change. So in this case, my elasticity of demand is 5 divided by 0.7.5. Can anyone do the calculation? I don't have a calculator. Sorry? 0.66. It is minus 0.66. If you ignore the negative sign, you notice that the absolute value of the price elasticity of demand is less than 1. So your demand is inelastic. So your demand 2 is inelastic. Your demand 1 is elastic, as we predicted. That's how you calculate price elasticity of demand. You find the old value of the price and the quantity. You find the new value of price and quantity. And you calculate the percentage changes and then take the ratios as I have just done. There is one big problem in this calculation. The problem with calculating price elasticity in this way is that when you move from A to B, the price elasticity of demand calculation is very different from when you move from B to A. But they should provide you with the same information because consumer behavior is changing exactly when you are moving from A to B or when you are moving from B to A. Are we all clear on that? From our demand curve, the behavior should be the same, but notice how different the calculations are. What we have just done is we assumed that our consumer was moving from A to B. Consumer was moving from A to B, original price was $4. The original quantity was 1,000, and at the new, the consumer's price and quantity are that. Now, what we're going to do, we're going to assume again our D1, but we're going to assume that our consumer moves from A to B, which means that we are now going to consider a situation where prices are going up rather than going down. By the same amount, from $3.70 to $4, and our quantity demanded is going to also decrease from 1,200 to 1,000. Same numbers, but notice that they're going to give you completely different elasticity numbers. So let's first find out the percentage change in quantity demanded, where now our old quantity is 1,200 and our new quantity is 1,000. So our new quantity is 1,000 divided by minus our old quantity divided by our old quantity times 100. So this is like minus 1,000 divided by 2,000. So you calculate those. Yeah, it's 1,200, right? What am I just saying? I apologize. It's 1,200, right? And it's 1,200 here. So that's. So it's minus 200 divided by 1,200. 2 cancels out. This is like 1 divided by 6, right? Do you all see that? Try to compare the percentage change in quantity demanded before. It was 20%. Now it is 1 divided by 6, right? Fundamentally different number, yes. Sorry? Oh yeah. Okay. Yes. Yes, you're right. It is that. I apologize. I'm making a lot of mistakes today. Okay, so that's that, and then you have percentage change in price where the new price is $4 and the old price is $3.70. So it is 4 minus 3.7 divided by 3.7 times 100. So I have 0.3 divided by 3.7 times 100. Could someone do the calculation? So what is 0.3 divided by 3.7 times 100? It is 8.1, and what was the percentage change in quantity demanded, which is 100 divided by 6? Can anyone do the calculation? Minus 16.7 divided by 8.1. Can anyone do the calculation? The 100 is in my numerator.
But it shouldn't be. It should be negative 1/6 times 100.
So this is 1200. So that's my 200. This is 1200. Yeah, it should be like, this is 100 divided by 6. So what's 100 divided by 6? 16.7 minus 16.7. So minus 16.7 divided by 8. How much do we have? Like some close approximation of 2, right? The numbers are fundamentally different. Do we all see that? This is 2.66, which is very close to being 3, and this is very close to being 2, right? So, although the magnitude is more or less the same, in the sense that both of them are indicating that your demand curve is elastic, but the numbers are very, very different, right? When we move from A to B, it tells us that a 1% decline in price increases your quantity demanded by 2.66%. When we move from B to A, it is telling us a slightly different information. What I am trying to say is that the way we calculate elasticity, if we calculate elasticity like the way we have just done, it creates the problem that your new value and old value becomes critical in finding the actual number of elasticity. So what people have done, they have come up with a little bit refined measurement of calculating price elasticity of demand. It still does not really resolve the problem that your elasticity of demand really depends on where you start and where you end up, but it does a better job. The second way of calculating elasticity of demand, and I want to make a very strong comment right now, and please remember it, because I will not repeat it again. Out of the two ways of calculating price elasticity of demand, unless otherwise stated, you should always use the second one. Unless otherwise stated. Unless it is told that you have to use a certain method, always use the midpoint formula to calculate price elasticity of demand, because you will be required to calculate price elasticity of demand. So what is this midpoint formula? The only difference in the midpoint formula is that when you calculate percentage change, you find the new value, you find the old value, but in the denominator you take a ratio of the new value and the old value. Notice how is this different from what we have been doing here. We have been calculating changes by taking the new value, subtracting the old value, and dividing it by the old value. Here, in the midpoint formula, you are taking both the old value and the new value, adding them up, and you are taking our average of that. So the midpoint formula sort of creates an average between the two ways we have calculated the price elasticity of demand. But this is a more accurate one. If we use that, so the midpoint formula is going to be calculated as follows. we are going to find the percentage change in quantity demanded by this, where Q2 is the new value, Q1 is the old value, but the denominator has a weighted average of these two values. We find the percentage change in price, which is new value P2, old value P1, divided by the weighted average of the price. Okay, so again the same problem. Imagine that we are assuming that our price is going down from $3.50 to $3.30. So we are indeed considering a price decline. And this is not now working at all. This is amazing. Okay. So we find first the average quantity, which is Q1 plus Q2 divided by 2. So that's what is happening. You find the average of these two. You find the average price, which is the weighted. You take the two prices, you add it up, just like what they are doing here. Then the percentage change in quantity demanded is going to be, you take the new value of the quantity demanded, which is 2,500, because we are assuming prices are going down. So if price goes down, your quantity demanded increases. 2,500 is my new quantity, 2,000 is my old quantity. I calculate the numerator as they are showing it, which is 2,500 minus 2,000. My denominator is the weighted average. You find the percentage change in price in the same way, and you find the denominator. Once you take the ratio of these two, you find that your price elasticity of demand is minus 3.8, where the absolute value is greater than 1, meaning that your demand is elastic. Okay? We hope to finish this chapter fairly quickly next week. So please, once you get the homework that is going to focus on previous chapters, try to finish it as soon as possible rather than wait till the last day. Have a nice weekend.